Good morning, everyone. I am a civil engineer. Today I will talk about dams. You can see this dam it is a gravity dam. Dams. Dam is an impervious higher water which constructed across a valley to form a storage reservoir. It's suitable in hilly regions where a deep gorge section is available for the storage reservoir. It means for serving multi-purpose functions such as irrigation, hydroelectric power generation, flood control, water supply, fishery, recreation. Next, type of dams. Based on materials of construction, rigid and non-rigid, based on structure behavior, gravity dam, arch dam, butters dam, or embankment. Basis on foundation, storage dam, detention, diversion, coffer dam. Based on hydraulic behavior, overflow dam, non-overflow dam. Gravity dam. What is gravity dam? A gravity dam is an engineering structure that by its own weight resists the forces imposed with a desired factor gravity. They are classified according to the material used for constructing them. Masonry dams. This type of dam is constructed with masonry. It could be either rubble construction, coursed masonry, concrete dams. They are constructed block by block by pouring good quality concrete. Components. Different component of a solid gravity dam or crashed. This is crashed. Freeboard is fill middle is fill way, slice way, toy, heel, gallery, freeboard. May forces. The force that act on gravity dam are self-weight, its hydraulic pressure, uplift force, wave pressure, wind pressure, seismic forces. Its forces that act on a gravity dam. Self-weight. The self-weight of a gravity dam is the main stabilizing forces which counterbalances are all the external forces acting on it. For construction of gravity dam, the specific weight of concrete and stone masonry should not be less than 24 kg per meter cube and 2300 kilogram per meter cube respectively. The self weight of the gravity dam acts through the center of gravity of the. It is calculated by the following formula: W equal to gamma into volume, where gamma is the specific weight of the dam's material. Hydraulic pressure, where pressure is the most major external force acting a gravity dam. On upstream phases, pressure exerted by the water is stored up to the full reservoir level. The upstream phase may either be vertical or inclined. On downstream faces, the pressure is external by tailwater. The downstream faces is inclined. It is the formula V equal to 1 by 2 gamma W into H square, where gamma W is unit weight of water. H is the height of water. Uplift pressure. The water stored on the upstream side of the dam is tendency to seep through the soil below foundation. We, while seeping, the water exert uplift force on the bases of the dam depending upon the headwater. This uplift pressure reduced the self weight of the dam. To reduce the uplift pressure, drainage galleries are provided on the bases of the dams. It is calculated by the formula U equal to 1 by 2 gamma W into H into B. V is the width of the bases dam. Wave pressure. When very high wind flows over the water surface of the reservoir, waves are formed which exert press- pressure on the upstream part of them. The magnitude of waves depend upon the velocity of wind, depth of reservoir, area of water surface. It is calculated by the following formula: V equal to 2 into 4 gamma W into HW. HW is the the wave height of wind pressure. The top exposed portion on the dam is small and hence the wind pressure on this portion of dam is negligible, but still an allowance should be made for the wind pressure at the rate of about 150 kg per meter square for the exposed surface area. The upstream and downstream forces. Seismic forces. Dams are subjected to vibration during earthquakes. Vibration affect both the body of the dam as well as water in the reservoir behind of them. The most danger effect occur when the vibration is perpendicular to the faces of the dam. Body forces act horizontal at center of the gravity and calculated as Pm equal to alpha into W. Water vibrations produce a water on the dam acting horizontal and calculated by Pw equal to 2 by 3 C into alpha into H square. This is the joints. Construction joint, contraction joint, transverse joint, and longitudinal joint. This is very important joint. Construction, contraction, transverse joint, longitudinal joint. Construction joint. There are horizontal joints provided for ease in construction of the gravity dam. They also permit systematic, convenient, and economical construction of the dam. The thickness of each layer of concrete should not exceed 1.5 meter. The thickness of first layer of concrete above rock foundation should not exceed 7.5 meter. Contraction joint. Contraction joints are provided to avoid cracks caused due to shrinkage of concrete due to temperature changes. Contraction joints are of two types. Transverse joints. These joints are continuous from upstream to downstream. Longitudinal joints. These joints are staggered or broken. The limiting conditions is H equal to sigma c upon gamma 1 plus s. Practical profile. Various parameters in fixing the parameters of dam section are freeboard. IS 65 12 1972 specifies that our freeboard will be 1.5 times of the wave height above normal pool level. Top width. The top width of dam is generally fixed according to requirement of the roadway to be provide the most economical top width. The dam is 14% of its height. Economical height. The cost of construction of dam increase with the increase its height. The height should be such that it gives more storage capacity at maximum cost. This height is considered to be economical height. To calculate the economical height, storage capacity for different height of dam are calculated and the cost of dams are worked out and plotted in graph with height of dam versus cost benefit ratio. The height of dam is economical when the cost benefit ratio is maximum. Low gravity dam. Low gravity dam, we can see a low gravity dam is designed on the basis of its elementary profile where the resultant force passes through the middle third of its base. Principal stress is given by gamma sigma equal to gamma h into s minus plus 1 where a principal stress gamma equal to unit weight, s equal to specific gravity and c a constant. The principal stress varies with h as all other terms are constant to avoid failure of the dam of should exceed allowable working stress F equal to gamma h into s minus c plus 1. High gravity dam. The high gravity dam is complicated structure where the resultant force may pass through a point outside the middle third of base. The section of dam is modified by provide extra slope on the upstream and downstream side. The condition of height gravity dam or H greater than F into W S plus 1 where F this formula is very important. Allowable working straight. Failure of gravity dam. Failure of gravity dams occur due to sliding. It may take place on a horizontal joint Above formation on the foundation sliding takes place when total horizontal place forces are greater than the combined shearing resistance of the joint. The static friction induced by total vertical forces. Overturning. The dam fails in overturning when total horizontal forces acting on the dam section are quite great in comparison with total vertical forces in such causes the resultant of two passes outside of the limit. The beam dam may fail when tension is produced in the concrete. Dam may fail in crushing. Precautions against failure to prevent overturning the resultant of forces acting. The dam should retain with the middle third of the waist width of dam. In dam, the sliding should be fully resistant when the condition for no sliding exists in the dam section. In the dam section, the compressive stress of concrete or masonry should not exceed permissible working stress to avoid failure due to crushing. There should be no tension in the dam section to avoid the formation of cracks. The factor of safety should be maintained between 4 to 5. Temperature control during setting of concrete, heat of hydration is evolve producing internal temperature stress resulting in development of internal cracks can get formed. To control the temperature, the following steps may be taken. Low heat cement may be used in concrete. The water course aggregate should be cooled down 5 degrees centigrade to be suitable means before mixing. During laying, the height of concrete blocks should not be more than 1.5 meter. It helps radiate heat to the atmosphere more quickly. The water is cooled by crushed ice before using it for the curing purpose. Curing purpose. Advantages. Gravity dams are more suitable in narrow valleys. Maintenance cost is lower. Failure the these dams is not very sudden. Gravity dam may be unbuilt to any height. Loss of water and seepage in gravity dams is less. Disadvantage. Initial cost of construction of gravity dams is very higher. Gravity dams of greater height can only be constructed on sound rock foundation. Require skilled labor for construction. Design of gravity dams is very complicated. Some famous gravity dams: Bhavani Sagar dams, Indra Sagar dams, Bilaspur Sagar dams, Tugabhadra dams. Thank you, friends.